and then our upcoming speakers. Okay, so our next talk, if we can load it up, is going to be by Joel Levine on the impact of lunar dust on human exploration. All right, well, thank you. Thank you, Joel, and take it away.
Well, I'm certainly very pleased to be here today and participate in the meeting. The impact of lunar dust on human exploration, identifying the problems and knowledge gaps. Next. I want to start the talk by pointing out an important quote by Apollo 17 astronaut Eugene Cernan. And this is a quote: "I think dust is probably one of the greatest inhibitors to a nominal operation on the moon. I think we can overcome other physiological or physical or mechanical problems except dust. One of the most aggravating, restricting facets of lunar surface exploration is the dust and its adherence to everything, no matter what kind of material, whether it be skin, suit material, metal, no matter what it be, and its restrictive friction-like action to everything it gets on." Next. And I put this quote in from Apollo 12 astronaut Alan Beam because he points out that even once you leave the surface of the moon, there are problems. And this is what Alan Beam reported. "After liftoff, a great quantity of dust floated free within the cabin. The dust made breathing without the helmet difficult, and enough particles were present in the cabin atmosphere to affect our vision. The use of a whisk broom prior to ingress would probably not be satisfactory in solving the dust problem because the dust tends to rub deeper into the garment rather than to brush it off." Next. Jim Geyer at the NESC, NASA's Engineering and Safety Center Lunar Dust Workshop that took place almost exactly a year ago at LPI, identified 9 different areas of dust-related problems: vision obscuration, particularly on landing, false instrument readings, dust coatings and contamination, loss of traction, clogging of mechanisms, abrasion, thermal control problems, seal failures, inhalation, and irritation. Jim Geyer checked the transcripts of all of the post-mission interviews of all the Apollo astronauts. The reference to his paper, which is actually online, is a very worthwhile summary of everything the astronauts reported. And I recommend this paper as required reading for anyone looking at the dust problem. Next. What we did is February 11th to 13th, almost 1 year ago, NASA's Engineering and Safety Center, the Lunar Planetary Institute, USRA, JPL, and the College of William and Mary hosted a workshop, Lunar Dust and its Impact on Human Exploration. We had over 150 people. We invited 12 keynote speakers, and we had another 30 contributed papers. Next. We, after the first day, divided the group into 3 panels: lunar dust composition, structure, and distribution. Panel 2, the impact of lunar dust on human health. And panel 3, the impact of lunar dust on surface systems and operations and techniques and technologies to reduce and mitigate these effects. Michael served as one of the moderators on this panel. Next. Now, if you're interested in the abstracts or more about the workshop, things are still online on the LPI website. General information about the goals of the meeting is the first citation. And all of the abstracts, the contributed as well as the invited were 5 pages. So with references, it's a good source of information. Next. There were 2 products of the workshop. The first is an NESC report, which is a summary of the workshop. That was released in 2020, and I have the where you can find it on the next slide. And the second, a 300-page book on workshop proceedings, which was scheduled to be published this month, February. I actually received the first copy of the proceedings a few hours before this workshop, so it's out. Next. The lunar dust and its impact on human exploration, NESC workshop report. It's about a 70-page report. It's available online from the NASA Engineering and Safety Center, who sponsored the workshop. Next. Let me tell you some key questions that came up at the workshop and give you some of the conclusions. The first is, what are the particle size distribution, mineralogy, chemical composition, and possible toxicity of lunar dust, especially for particles less than 50 microns? Second group of questions. This is all from the report, the NESC report. What processes or mechanisms control the transport and dynamics of lunar surface dust? Number 3, what are the electrical and magnetic properties of lunar dust? And what techniques and technologies are needed to reduce, mitigate lunar dust impacts on the astronauts, their equipment, their habitats, and spacecraft? Next. Let me give you 2 conclusions of the workshop report. These are quotes. Prior to the first autonomous human landing on the moon, we must better understand the particle size distribution, structure, chemical composition, potential toxicity, magnetic and electrical properties, and the dynamics and distribution of lunar dust. Next. And this is my, my final chart. This was one of the major workshop conclusions in the report. The lunar dust problem is an agency and industry concern affecting most mission subsystems, and it must be addressed. So I'll conclude with that chart. I finished with 2 minutes left to make up some time. Thank you very much, Michael and Jorge, for inviting me. Thank you.
Thank you, Joel. That was fantastic. And yes, thank you for the couple extra minutes you provided